Hello, hello, anyone is in live? Is anyone is in live? Good evening, Amit. Good evening, good evening. Any any other is in live? Good evening, Akshara. Good evening. Any other still? Good evening, Joshita. Good evening, Samantha. Samantha, may I know who is this name? Name of this Samantha? This is Samantha. Sorry, Samantha. Sorry, Samantha. Samantha. May I know from which stream this Samatha belongs? Gautam. Acha, acha. Okay, Gautam. Fine. Okay, Gautam. Right. Right. Now, if you are coming, if you are joining the live from your any of your parents or any of your respective brothers or anyone, just say me your name. Clips ab Assalamu alaikum. Walaikum salam. Now, hi, Stun. May I know your name? May I know the name? Stun. Uh, if the name, if it is there, so that I can pronounce your name, so that it will be easy for me instead of the names which you have given. Aha. Okay, Prashant. Okay, hi. Okay, done. If your names If you have said your name means so that it will be easy for me. Okay, Prashant. Okay, fine. I got it. So that it is easy for me to pronounce your name instead of the names which you have provided here. Rest other any other? Hi Radha. Hi. Good evening. Good evening. Now, right. Okay. Now, shall we start our lecture? Shall we start our lecture? Okay. Prashant, okay. Done. Rumana, good evening. Good evening, Rumana. Good evening. Prabeen. Ram, Prabeen. Right. Now, now I will start the, yes. Now I will start the class. Right. Now we'll start the class. Yes, sir. Okay, fine. Still where the last class has done, may I know? Can anyone say? Last class, I think so. We have done up to question, I think so. The energy, units of energy, that all the questions we have did, I think so. Now in this class, we are going to study about which one? About the photoelectric effect and the black body radiation. Clear? Now In this lecture, we are going to see about the Planck's quantum theory. About the which one we are going to see? We are going to see about the Planck's quantum theory, right? Yes. Now here we are going to see Planck's quantum. In this Planck's quantum theory also done, right? E is equal to h nu. I think so. I explained. Then we'll do some graphs. I think so. The Planck's quantum theory, the formula we got E is equal to n h nu. E is equal to n h c by lambda. This is the formula we got from the Planck's quantum theory. Done. Then after that we have to do some graphs. Okay. Now E versus lambda. May I know how the graph we will get E versus lambda? Now E versus lambda graph and E versus nu graph and E versus wave number graph. E versus wave number graph, E versus nu graph. May I know how the graph you will get? How the graph you will get for the first one? How the graph you will get for the second one? How the graph you will get? The third one, how the graph you will get? May I know how the graph you will get? May I know the graph how we will get? No. This is E is inversely proportional to the lambda, right? E is inversely proportional to the lambda. If the E is inversely proportional to the lambda means this rectangular hyperbola we will get, right? In this manner we will get. No. Here the E is inversely proportional to lambda, right? Then the frequency one will get the straight line. Hi Yashwant, hi. Hi. Now E is equal to, now the graph E is equal to, here you can see E is directly proportional to the nu. If the E is directly proportional to the nu, the straight line we will get. Good evening Yashwant, good evening. Straight line for the wavelength. No. Parallel to x-axis. Which one parallel to x-axis? No. Here the graph you will get decreasing rectangular hyperbola for the E versus lambda. Now this one E is equal to, now straight line from the origin E versus which one? Frequency, and straight line to the origin also E is equal to wave number. Now this you have to be very careful, right? And the now dissociation of the wave, the photo dissociation. Now in this photo dissociation, hi Suraj, hi. Now if now the splitting of the wave and the splitting of the frequency. What is the splitting of the wave and the splitting of the frequency? If any object, if it is there, now if we are passing the radiation, it is having the nu, and this nu has splitted into the nu 1 and the nu 2. Clear? Then if they ask in the questions, how they will ask you, one of the, either they may give the frequency of the incident light and one emitted light frequency they will give you, and they will ask you the another frequency of nu 2 which it has emitted. For that one we are having the formula. We know energy is equal to E1 plus E2. Then this energy nu will be equal to h nu is equal to this one h nu 1 plus h nu 2. Here if you take the HH common, h nu is equal to h into nu plus nu 2. Here the HH get cancelled. Nu is equal to nu 1 plus nu 2. Now this is the formula we are having. Done. Now if you go it for the same one, if they are asking for the wavelength, Now photo dissociation for this wavelength, if they ask, now here the wavelength, it will be splitted into the two. Now here the wavelength 1. Now this is a wavelength 2. Clear? We are passing some wavelength. Now here the E is equal to E1 plus E2 here also. But we know the formula. What? E is equal to hc by lambda. E1 energy formula. Now here it is equal to hc by lambda 1. Here the hc by lambda 2. Here the hc is common. It can get cancelled. Then 1 by lambda is equal to 1 by lambda 1 plus 1 by lambda 2. Clear? This is some formulas we have studied. These are the very important. Now the direct questions they may ask. Clear? Next one we are going to see the photo dissociation. This photo dissociation question we used to see on the basis of one question. Photo dissociation, this we are going to see on the basis of on one question. What is the one question we are going to see? Here he is asking calculate the wavelength of radiation, which this is which, don't get confused, this is indicates that which would cause photo dissociation, which could cause photo dissociation of Cl2 molecule, which would cause Cl2 molecule is C bond Cl bond energy is 243 kilojoule per mole. 243 kilojoule per mole. Clear? Now, hi RJ, hi. May I know who is this RJ? Now we'll see. Here, what it is saying, per mole you are saying. You have to be very careful with this type of the units they have given. Per mole you are saying. Now 243 kilojoules of energy is required to break the 6.023 into 10 to the power 23 bonds. Clear? Then to break the one bond, how much energy or how much bond energy we require? Clear? Hi Kirtan, hi. Now, how much bond energy we require? Now, you have to be very careful with this one. One photon can break only the one bond. Which one? One photon, you have to be very careful. One photon can break only one bond. One photon can break only one bond, right? Now, the energy will be. Now, good evening, Vishnu. Good evening. Right. Now, 243 by 6.023 into 10 to the power 23 is which one? The bond dissociation energy. Clear? Bond dissociation energy. This is a bond dissociation energy. It has came. Now he is asking the which one? Wavelength is asking, right? Wavelength. Then how to calculate the wavelength? E is equal to h nu. E is equal to h nu, right? Then if you expand E is equal to hc by lambda, then lambda if you take it to the left hand side, hc by E. Okay Ram, okay, fine, done. Now h we know, right? 6.6 into 10 to the power minus 34, and speed of the light we know 3 into 10 to the power 8, and energy how much we got to break the one bond? To break the one bond, the energy we got 243 by Avogadro number. 243 by Avogadro number. If you divide the 243 by Avogadro number, 6.023 into 10 to the power 23. Now if you take it to the numerator, may I know if you calculate, can anyone say me what is the answer for this one? After the calculating, can anyone say me the answer for it? 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 4.90 into 10 to the power 52. Okay, good. Okay, fine. Right. Right. Okay, fine. Good, Suraj. Good. And the students who are trying also good. VVV good for all. VVV good for all. Especially VVV good for the NEET students. NEET students, VVV good. NEET students are NEET. JEE students are GEMS. MSET students are excellent. Right. 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 I can't hear. Suraj, you have said the answer, but it is not appearing. Yes. Okay. Right. Now, the next concept we are going to move. The next concept we are going to see, that is the photoelectric effect. That is photoelectric effect. Now, this is a photoelectric effect. The blank has did the experiment. Now, here, NEET students are NEET. Okay, JEE students are GEMS and the MSET students are excellent. Okay, my dear GEMS, NEET and the excellent, listen carefully to this concept. Now, my dear friends, I did not calculate it exactly. I hope you are calculated from your end. Then now the photoelectric effect. Now the students who are in the live, try to be more conscious. I will show you the digital photoelectric effect, how the photoelectric effect will be works. Now we can see here. No, wait, I will show you the how the photoelectric effect will be works. Wait. Individually, my dear friends, actually my intention is to give the free content for the students who are very much interest for the JEE. Actually, individually, if I take, what it will happen, if the individually if I take that, when I was explaining, it will be well and good for you, but after the some days you will get forget about it. Now, I hope this is visible for you. This photoelectric effect is visible for you. Wait, let me try. Uh, I hope it is clear. Everyone, is it clear? I hope it is clear. I think so. Yes. Now we'll see. Here, right. Now listen. Now in this photoelectric effect, now what are the effects we are going to see? Now we'll see. Here first I was taking the one, I was changing the metal. Here I was changing the metal to sodium. Now sodium, you can see the work function of the sodium. Now wait, I was decreasing the wait. Now let me reload it from the starting. See, yes, it is concluded that it is having the particle nature. Now you see, now listen, here I was changing the metal to sodium. Okay, when I was changing the metal to the sodium, now here the light work function I was sending, you can see 2.48 electron volt. Now due to the 2.48 electron volt, the electrons which are present in the sodium, it is exciting. You can see here in the graph, you can see now, if you can see here, still if I increase the my wavelength, if I increase the energy, see, kinetic energy of the electrons are increasing. You can see kinetic energy of the electrons are increasing on the graph. If I increasing the incident light, now the electrons to eject out from the metal, it requires only 2.27 electron volt, but I was sending the 4.12 electron volt. Then the 2.27 it has utilized, the remaining it has been converted into the work function. You can see on the graph, when I was increasing the incident light. Is it clear? Done. Vishnu Teja, be concentrate on the concept. Rest others think we can do. First be concentrate on the concept. Now you can see here, now as I was increasing the, now I will decrease the wave function. Sir, whatever the incident light we are sending, now I was sending it, now the work function or the incident light I was sending less than the work function of the sodium metal. Now you see, I was sending the 2.19 electron volt. When I was sending the 2.19 electron volt, now you can see, now electrons, the metals are, the electrons which are there in the sodium, it is not getting excited. చూడండమ్మా, ఇప్పుడు 2.19 ఎలక్ట్రాన్ వోల్ట్ సెండ్ చేసినప్పుడు సోడియం మెటల్ లో ఉన్న ఎలక్ట్రాన్ ఎజెక్ట్ అవ్వడం లేదు. ఎందుకు? I was sending only the 2.19 electron volt. The 2.19 electron volt of the energy, what? It is not sufficient to eject out the electron of the sodium. That's the reason there is no any what photoelectric effect it is absorbed. Now ఇప్పుడు చూడండి, now what I will do, now I will increase the which one? Now the incident light energy. Now when I was increasing the incident light energy, now you can see same, I made it as same 2.27 electron volt I made. When I made it as a both the 2.27, just you can see electron is striking. Now just I will increase the 1 electron volt, 2.29. If it is happening, just electron is ejecting out. Now you can see, as the electrons are ejecting, now the kinetic energy of the electrons are increasing. You see, as I was increasing the incident light energy, kinetic energy of the electron is also increasing. Done. Now the next concept we will see here, this sodium metal, two electrons to eject, this sodium metal, this electrons to eject. Now here I was taking the one zinc. Now again I will take the sodium. Now is sodium. Now the sodium I was sending the energy which is less than 2.7 electron volt. Electrons are not coming. Then when I was made it to the 2.27, just electron is striking. Then after when I was increasing the electron volt, Now the kinetic energy of the electron is also increasing. When I was increasing the electron volt, the kinetic energy of the electrons are also increasing. Then after that I will increase the light intensity. Light intensity, and what happened to the kinetic energy of the electrons? Now we'll see. Now we'll see if I increase the light intensity and what happened to the kinetic energy of the electron. Now we'll see. Now if I was increasing the intensity of the light, more the intensity of the light if I was increasing, now you can see there is no any change in the kinetic energy of the electron. There is no any change in the kinetic energy of the electron. Is it clear? Is it clear? Is it clear for everyone? Right. Right side is a graph. That graph indicates that now how much energy we are sending, that is a graph. Okay. Right. Now I hope that it is clear. I think so. Photoelectric effect. Right. Now the website name is Javlab. The website name is Javlab. Now you can cross check over there. Javlab is the one website. It is there. There you can get. Okay. Fine. Now we'll start our lecture. Now the photoelectric effect we know. Now the photoelectric effect is the support of particle nature of the light. What? It is a support of particle nature of the light, right? Now the photoelectric effect is a particle nature of the light. Now I will ask you some questions. Now you have to say me. Now if I was sending the energy which is less than the threshold frequency of the metal, will the photoelectric effect will be happen or photoelectric effect will not be happen? Will the photoelectric effect will be happen or the photoelectric effect will not be happen? Now the students who are in the live, they have to say me. Now, try to say me. Now the photoelectric effect to be happen, no photoelectric effect will be happen by the Joshita. Yes. By Suraj also. Good. Kirtan, no. Good. Sri Vaishnavi, good. No. A photoelectric will not take place. Good. Good, Nana. Good. Right? Photoelectric effect will not be happen. Now you say me if I was good. If I was sending the more than the energy, more than which one? Work function of the metal. Will the photoelectric effect will be happen? It will be happen. Now here whatever the photoelectric effect, Vishnu Teja, okay, good. Vishnu Teja, you have said good. Okay, fine. You have said first. Okay, fine. You have said first. Now, VVV good for the each and every student who are seeing the live as well as the who has said the answer. Now, good evening, Praneeth. Good evening. Right. Vishnu Teja. Right. Now we'll see the photoelectric effect. Now what is the photoelectric effect? Here in this photoelectric effect, now I was not writing any points, my dear friends. I was not writing any points, so better you can refer to the notes. Now You can refer to the notes so that the points are there. Just our intention is to cover the most of the topic. Done. Now if the energy is fall on the metal, now this electron is collected by the metal. Clear? The electron is collected by the metal. Done. And that metal, whichever when the energy is fall on the metal, that metal is ejecting the electron. That ejected electron is collected by the collector, and that collector will send it into the circuit, and that circuit will send the in the opposite direction. In the opposite direction, it will send a what? It will send the current. Clear? Now these points already it is there in your notes, right? So there is no need to write the points again. Now, what does it mean? Clear? The first we are going to see, when the light is incident on a certain metal, electrons will be ejected out from the surface. This is called as a which one? Photoelectrons or photoelectric effect. Now, what is the formula that we got it by the? What is the formula of the photoelectric effect we got? Now the main formula we got it as a work function. In the less time we can cover the more content, Nana. If we are writing the each and every point means it will take more time. Now the work function of the metal, it is given as work function psi is equal to h nu naught. This h nu naught is nothing but threshold frequency. This is nothing but threshold frequency. Okay. Now the work function we can write it in this manner also. Hc by lambda naught. Hc by the lambda naught. Okay. Right. Now may I know the what is the formula of the Einstein mathematical equation formula? H nu is equal to h nu naught plus kinetic energy. Good. Good, my dear Vishnu Teja. Good. Now here how that formula has came. Now any metal to show the photoelectric effect. Now when we are passing the energy, now if that energy, if it is matched to the work function of that metal or threshold frequency of the metal, then what will happen? Electron will be ejected out. It will be utilized. If let's suppose this electron to eject out from the metal, let's suppose it require 2.42 electron volt. Then if I was sending the energy of the 2.32 electron volt, then what happens? Electron will not be ejected out. Then there is no any photoelectric effect will be happen. Okay, done. Then if I was sending the which one? Photoelectric effect or the energy. No, already you are it is there in your notes, right? Already I was given in your notes, right? Just to keep it your notes in front of you and try to see the lecture. That's it. Anyone new? Anyone other than anyone are seeing newly? No, right? Most of them are having the notes only. So better the class revision will be happened. Right. Okay. Right. Now based on that, here the right. If the what are the main points that we got for the photoelectric effect? The main points we got it for the photoelectric effect, that is a E is equal to work function into work function. E is equal to work function plus kinetic energy. Now here E is equal to h nu, work function is equal to h nu naught plus kinetic energy. This formula we can write it in this manner also. E is equal, if you bring the h nu naught to the left hand side, nu into nu minus is equal to kinetic energy. Done. Now when will be the photoelectric effect happen? When will not be the photoelectric effect will not be happen? Now we see. If nu is less than work function, no photoelectric effect. Done. If nu is equal to nu naught, no photoelectric effect, just electron strikes, that's it. but it will not come out from the metal. Then if the nu is greater than incident light is greater than which one? Threshold frequency of that metal, then the photoelectric effect will be occurs. Now we'll see the graph between kinetic energy versus nu incident light, which are we are incidenting on the which one, the light which are incidenting on the metal. So I will write the four graphs among the 1 2 3 4, which is the correct graph you have to say me. Done. Now this is a first graph. Now the second graph, kinetic energy versus nu. This is the second graph. Now the third graph, kinetic energy versus nu. This is the third graph. And the fourth graph, kinetic energy versus nu. Among the 1 2 3 4 graphs, which is the correct graph for the kinetic energy versus nu? What is the correct graph that we are having the kinetic energy versus nu? What is the correct graph that we are having for the kinetic energy is equal to nu? Ah, yes, yes. Clips up. Good. May I know the name of yours? Clips. Yes. Good, Nana Joshda. Good. Good, good, good. Suraj, good. Good, Pranit, good. Sir, 2 looks good. But your answer is wrong. It is looks good only. But the answer is wrong. Good, Akshara, good. Vishnu Teja, don't be so smart here. Be focused on the concept. The same thing if you choose in your exam, that smartness makes your what? Right. The answer is 3. Kinetic energy and the incident light. Here the y is equal to mx minus c. Clear the graph you will get, we know, right? Kinetic energy is equal to h into nu minus nu naught. Then this one we are having the, this is y. Now this is a x and this is a minus c. Y is equal to mx. Ah, yes, yes, I have seen. Good, good. Okay, fine. Now in this manner we'll get the graph. Now if now you have to say me kinetic energy of electron, kinetic energy of electron. Now intensity of light, kinetic energy of the electron and the which one, light intensity, intensity of light. The graph you have to say me. How the graph you will get? Kinetic energy of electron and intensity of the light. Intensity of the light, kinetic energy of the electron and the intensity of the light. How the graph you will get? How the graph you will get? Now you have to say it. Now we'll see how many of you will say the correct. Kinetic energy of the electron and the intensity of the light. Kinetic energy of the electron and the intensity of the electron. Kinetic energy of the electron and the intensity of the light. Parallel to the intensity. Good, good. Parallel to the x-axis. Good, 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 good. Parallel to the x-axis. Good, good, good. Why? Because why it is a parallel to the x-axis? Because if you take a metal, now the electrons to eject out parallel to the intensity. Good, Amma, Akshara, good. Now, if the electrons to be eject out from the metal, it requires, let's suppose it requires 4.2 electron volt, let us assume. Good, Suraj, good. Now, here, if I was passing the, now, Max to max, I can try to say it in English, but Hindi it is very difficulty for me. My dear friend who are in the live from any other state other than the Andhra Pradesh and Telangana, I can say in English because max to max I don't know the Hindi. My Hindi is very poor, so I can teach you in the English itself. Okay, now you see, if this electron to eject out from this electron to eject out from the metal, it requires how much? 2.24 electron volt. So I was sending how much? 2.52 electron volt. But this energy is coming in the form of the small bracket, right? It is coming in the form of the small packets like the quanta. Done. Now what I was doing, the intensity. What is the meaning of the intensity? Many of the lights I was sending. Many of the lights I was sending. If it is coming 5 means, now it is coming 10. So one photon, already I explained you very clearly. One photon can eject one electron. One photon can eject one electron. If the one photon is ejecting one electron means here Heisenberg uncertainty principle, like position. Now, Joshita, Heisenberg uncertainty principle. Yes, yes. Now, Heisenberg uncertainty principle, mainly they will ask you. Now, uncertainty in position and uncertainty in the momentum equal to h by 4 pi. Either they may ask uncertainty in the position, either they may ask in the uncertainty in the momentum. Sometimes they may ask uncertainty in the velocity. How to calculate the uncertainty in the velocity? Momentum is equal to mass into velocity, right? Then you can put it here. M into delta V by h is h by 4 pi. Then delta V is equal to h by 4 pi m into delta x. This is also one type of the formula they can ask. Based on this formula also they can ask the questions. Is it clear? Is it clear, Joshita? Right. Now, next one. Okay, this is a one very important formula that we are having for the photoelectric effect, that we have to be very careful with these questions. Okay, done. Next we are going to see the stopping potential. I will cross check once the now Captain America, once the my class done, I will cross check the your mail ID. I will cross check the mail which you have texted or which you have sent it to me. Okay, once the live end. No. Right. Now, right. Now what is the meaning of the stopping potential? Now what is the meaning of the stopping potential? Stopping potential means now the minimum energy required to stop the kinetic energy of electron. See, what is the meaning of the stopping potential means? Now we know the what? We know this one. This is a electron. Now the electron, when we are sending the energy or when we are sending the energy to this one, what happened when this electron has been minimum energy? If it is a 2.42, now if I was sending the 2.52, the kinetic energy of this electron is 0.52. Now this 0.52 of this kinetic energy of this electron we have to stop, that we call it as a stopping potential. Kinetic energy of the electron we have to make it as 0. Okay, minimum energy required to stop the kinetic energy, that this kinetic energy of the electron we have to make it as 0. So for that one, now the formula we are having h nu is equal to h nu naught plus half m into Vs. This is a stopping potential. So the half mvs square is equal to half mvs square is equal to plus h nu naught is equal to h nu. This is a kinetic energy, this is a kinetic energy formula, or this is a stopping potential formula. Okay, right. And the next one, the next concept we are having, that is black body. The next concept we are having the black body. Now the black body is the concept. In a practical, there is no any such a black body. It is there. The radiation which is emitted is called as the black body, it has said. Now the black body mainly it has explained on the basis of the graph. Now if you take the any iron rod and if you heat it at the different temperatures, it is generating the different intensity or different frequency. Now you can see, we know here this is at the T2 temperature. There is no any perfect black body in our universe. Yes, this is at the T1 temperature and this is at the T2 temperature. Now this is wavelength. This is wavelength. Now you can see, lesser the wavelength, higher the wavelength, lesser is a which one? Frequency. Now lesser the wavelength, higher is the frequency. Higher is the frequency. Done. Now we know, right? Frequency is equal to c by lambda. If the frequency increases, nu decreases. Now this is only said by the black body. The most of the points that here we are going to see is only on the basis of black body. This black body and the photoelectric effect is only the what experiments did to show the light is having the particle nature, and the Maxwell has said that, James Maxwell has said that light is having the which one? Wave nature. So by that we got to know that light is having the particle nature as well as a wave nature. Then after that, the next we are going to see the very important model, that is a Bohr's model and the Bohr's postulate. So here what I will do, my dear friends, now the Bohr's model and the Bohr's postulate, this is very important for your JEE mains as well as NEET as well as for the EMSET if you are preparing, or else if you are preparing for the any other entrance exam and for your IPE also. IPE exam also it is very important. Done. Now what I was doing, now I was not writing any postulates here. My dear friends, you have to be very careful here. I was not writing any postulates because already the postulates are in your book. So that postulates, what you do, just revise that 6 postulates, but I will explain the one very important postulate of the Bohr. What is the very important postulate of the Bohr? Yes, for the CBSE also, whatever may be, for the JEE, NEET, MSET, for the IP and any other entrance or any other CBSE, ICSE, all the boards it will be useful for you, right? Now the boards, can anyone say me what is the main postulate of the Bohr that he has given? That main postulate was derived by the de Broglie. Hi Sri Ganesh. Hi. Now is my question is clear? Is my question is clear for everyone? Is my question is clear for everyone? What is the main postulate of the Bohr that he has given? That main postulate of the Bohr was derived or concluded by the de Broglie. Whatever the postulate that Bohr has given, that de Broglie has proved. Now what is that main postulate? Can anyone say me that postulate? Is my question is clear? If it is clear, try to say me. If not, if my statement, if it is not clear, good Suraj, good. MVR is equal to NH by 2 pi. Good. Right. The main postulate of the Bohr as given that good Yashwant, good Pranit, good. Right. Now the main postulate of the Bohr as given that angular momentum. Okay, good Nana, good. MVR is equal to the electron will revolve in the fixed circular orbit in which whose angular momentum MVR is equal to NH by 2 pi or integral multiple of NH by 2 pi he has said. Good Nana, good. Good Akshara, good Vishnu Teja. The main postulate he has said that electron can revolve only in the orbit in which angular momentum MVR of electron is integral multiple of NH by 2 pi or NH by 2 pi means MVR is equal to NH by 2 pi. MVR is equal to NH by 2 pi. Here the N is equal to number of shell or orbit. This is a one very important postulate that Bohr has given. Then the same postulate was proved by the de Broglie, right? Now, next. These are the next the Bohr 6 postulates, whichever he has given, that you once you revise it in your which one? Try to revise it in your notes. Now the next we will go to the which one? Derivation of the Bohr. Now we'll go to the derivation of the Bohr. Now this is very important, my dear friends. Now be ready with your pens. Now once the derivations and the formulas done, now I will start the question section. Now here we are having the three. One is NEET, one is JEE, one is the MSET. Concept is same for all and the level of the questions are also same for all. Now we'll see who will say the answer first. NEET of NEET people, JEE of GEMS people, or MSET of excellent people. Now we'll see. Now the first the derivations of the Bohr. Now in the derivations of the Bohr, the one very important postulate he has said that when the electron is revolving in the fixed circular orbit, now this electron is expressing two forces. One is electrostatic force of attraction and one is a centrifugal force to the opposite direction. Electrostatic force of attraction as well as a centrifugal force. Then electrostatic force of attraction formula we are having yesterday also I said electrostatic force of attraction formula equal to centrifugal force. Now here electrostatic force of attraction is equal to kz e square by r square, and centrifugal force, that electron is having certain mass and it is moving with a certain velocity in this radius, that is equal to mv square by r. Then here next, here for this one what I was doing, this r and this r will be get cancelled. Then if you take the r to the left hand side, then the r, if you take the r to the left hand side, then what happened, kz e square by mv square, kz e square by the mv square, that is equation number 1. The second one, the next he has given the one postulate, right, that is MVR is equal to NH by 2 pi. Then R is equal to NH by 2 pi MV. R is equal to NH by 2 pi MV. Then if you equate the 1 as well as if you equate the 2, then what you will get? What you will get? 1 is a KZE square by MV square is equal to NH by 2 pi MV. NH by 2 pi MV, and here the square V and the V will get cancelled. Done. Then V is equal to KZE square, and here the MM also get cancelled. Then KZE square 2 pi by NH. Clear? This is the one formula we got. Then V is equal to, now separate the variables, and here the Z and the N are the variables. Now the constant values are this permittivity constant, the value is fixed. Now electron charge is fixed, 2 pi is fixed, and the Planck's constant value is fixed. Then here the variables are Z and N. Now by putting all these values, constant values, now the velocity of nth electron, how much we got and what is the formula? Now say me, the velocity of nth electron, what is the formula we got? What is the velocity of nth electron formula we got? What is the velocity of nth electron formula we got? What is the velocity of nth electron formula we got? Can anyone say me what is the velocity of nth electron? Right. Yes, good, Suraj. Now Z by N, yes, 2.18 into 10 to the power 6 Z by N meter per second. Wow, good. Akshara, good. Now, yeah, you know the formula, right? 2.18 into 10 to the power 6 Z by N meter per second. This is the velocity of an electron formula. Yes. Good, Nana. Akshara, good. Suraj, good. Anime boy, good. Joshita, good. Now, my dear friend, Captain America, I will see the mail after once this live ends. Let me complete the live. Once this live ends, I will see. Okay. Now, this is the velocity of the nth electron. In the middle of the live, I cannot see. In the middle of the live, I cannot shut down this class, and I can see after once this live end. Right. Next, we are going to see the radius of the and centimeter per square. Right. Next, we are going to see the radius of electron. Now, the radius of the electron formula we are going to see. Now, the radius of the electron formula that we are having. Now, R is equal to NH by 2 pi MV. Now, MVR is equal to NH by 2 pi. This was given by the Bohr in this fixed circular orbit. Now, whose angular momentum is the integral multiple of MVR is equal to NH by 2 pi, the Bohr has said. Then if I send this MV to the left hand side, R is equal to NH by 2 pi. 2 pi mv. Now this this is a v we got, right? Now you can see v is equal to kz square 2 pi h z by n. The same that I was multiplying here. R is equal to nh by 2 pi m clear, kz e square 2 pi h which is nh. Then if you simplifying all the constants and the variable, and if you separate out, that we got the n square h square by 4 pi square m k z e square, and the variables here we are having, that is r is equal to h square 4 pi square m 4 pi square k e square, and the variables are n square and n square and the k. Now if you apply all the constant values, now the radius of the electron, the radius of the nth electron formula, how much you got? The radius of the nth electron formula, how much you got? The radius of the nth electron formula, how much you got? The radius of the nth electron formula, how much you got? After keeping the all the constant values here, what is the radius of the nth electron formula we got? You have to say me in the picometer as well as good Sai Vaishnavi, good 0.529 n square by z angstrom, one in the angstrom, one in the picometer. Good Joshita, good Akshara, anime boy, good. May I know who is this anime boy? No. Good Suraj, good. Now may I know what is the answer for the in angstroms? What is the answer in angstroms? May I know what is the answer in angstroms? May I know what is the answer in angstroms? Angstroms, what is the answer? What is the answer in angstroms? Good anime boy, good. In the angstrom, n is equal to, yes, good 52.9 n square by z picometer. In the angstrom it is 0.529, in the picometer 52.9. Good Sai Vaishnavi, good Suraj. Right. Next we are going to see the another very important formula. That one, another very important formula. What is that another very important formula? We are seeing, that is circumference. Now this, the electron in the nucleus, the electron, if it is revolving to complete its one circumference, how much circumference, how much time it is taking, now we have to see. Clear now, we know the circumference is directly proportional to the r, and that r is directly proportional to the n square by z. Sir, how come it r has came, sir? Now you see, circumference formula, circumference is equal to circumference of sphere or circle. Circumference of sphere or circle, what is the, now what is the formula of the circumference of circle? Now what is the circumference of circle formula? What is the circumference of circle? What is the circumference of circle? That is 2 pi r. That is 2 pi r, right? Then you can see the circumference is directly proportional to the r. Now r is nothing but radius of nth electron. Radius of nth electron is directly proportional to the n square by z. Yes, good Nana Suraj. Just now we have seen. Now the radius of right? Now you can see here the r is directly proportional to the n square by z. Here also circumference is directly proportional to the r. Now the r is directly proportional to the n square by z. Done? Is it clear for everyone? Is it clear for the everyone? Now we'll calculate how much time period this electron has take to complete its one circumference. Now for that one we are having the time period. Time period. Now the time period formula we are having circumference by velocity. Circumference by velocity. Now the circumference we got. Now the circumference what we got? Now the circumference is equal to n square by z. N square by z. And the v is z by n. Why? Velocity of nth electron is directly proportional to the z by n. Here we have seen. You can see this velocity of nth electron is directly proportional to the z by n. Then now here the time period that it will be calculated as a n cube by z square. N cube by z square. Right? Good, Ashwant, good. Good. Right. Now next, time period is equal to what we got? Time period is equal to n cube by z square we got. This is a formula we got for the time period. Now revolution per second they will ask. Revolution per second. Now the next type of the question they will ask you revolution per second. Revolution per second. Now for that one we are having the 1 by time period. 1 by time period. Now 1 by time period. Now the 1 by time period, how much we got? Time period is equal to n cube by z square, right? Now the 1 by n cube by z square. Now the revolution per second we got it as a z square by n cube. Z square by n cube. This revolution per second RPS. This revolution per second, sometimes they will ask you the value. For that one we have to take 6.6 into 10 to the power 15 into z square by n cube. This value already I explained. There is a one derivation, it is there. No need of remembering the derivation and all. Just there is no need of remembering the derivation and all. Just you remember this value, you will get the answer. Now I will write the one question. I will write the one question here. Now you have to be very careful. Yes, yes, good, good, good. Good, Nana, good, Bindu, good. Sorry. Good, Joshita, good. Yes, 6.6 into 10 to the power 15 z square by n cube. Good, 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 Suraj, good. Now I will write the one question. Now you have to say me the answer. Yes. An electron is moving. An electron is moving in third orbit. An electron is moving in third orbit of He plus atom or He plus of He plus. Electron is moving in third orbit of He plus. Now what is RPS of that moving electron? What is the RPF of that moving electron? What is the RPS of that moving electron? Can anyone say me the answer? Can anyone say me the answer? What is the RPS of that moving electron? Good, good, anime boy, good. Good, good. Clear? Right. Right, good, good. Good, anime boy. May I know what is your name? Anime boy, I was asking your name. 6.6 into 10 to the power 15 into z square by n cube, right? This is a formula for the RPS. Now the z square is asking for the, yes, no, 27. Sai Vaishnavi, once you cross check, because n cube, right? 3 cube is nothing but 27, right? Now he's asking for the helium. Then the helium Z square will be 4. Atomic number is 2. And here the n cube. N cube it is 27, right? Okay. 6.6 into 10 to the power 15. 4 by 27 is the answer. 4 by 27 is the answer. Next, the next one we are having. No need to simplify. Just you can say me the answer. That's it. Okay. Good. Everyone, good. Everyone, good. Now Vishnu, Akshara, Amit Dubey, and next Joshita. Right. Next question I will write you. Next question I will write. Now you have to be very careful with this question. If the radius of the second Bohr orbit, if the radius of the second Bohr orbit of He ion is 105.8 picometer, 105.8 picometer, what is the radius of third Bohr orbit of Li plus 2 ion? Now see the options carefully. Sorry, not the options. See the question carefully and try to give the answer. Okay. See the options. See the question carefully and try to give the answer. What is asking? Second Bohr orbit of the He plus ion is 105.8. Then what is the radius of the third Bohr orbit of Li plus 2 ion? Li plus 2 ion. May I know what is the answer you got? No. Anime boy, no. That's the reason I said you see the options carefully. Now I will write. Option A. No. I will write option A. I got it as 159 approx 159. Option B approx 162. Option C approx 170. Option D approx 180. If you know the answer, try to say me the answer. If not, I will explain. Now what is the answer? Among the A, B, C, D, now what is the option you got? Among the A, B, C, D, what is the option you got? Right. Good, Akshara, good. So 158.7. So approx answer is 159. Here you can see he has given the unit in the picometer. Good. Anime boy, good. Akshara has said first. The correct answer was said by the Akshara. V, good. Akshara, V, good. Good. Joshita, good. Suraj, he has tried good. Now, Suraj, he has tried good. Next, Praneeth, he has tried good. Good answer is 159. How the answer is 159, you know? Here, good, good, good. Good, Sri Ganesh, good. Now, he is asking ratio of which one? Ratio of the Li plus 2, sorry, helium plus by Li plus 2. Li plus 2, right? Now, this radius already how much they have given? 105.8 picometer they have given. Picometer. Done. And is asking the radius of Li plus 2. We know the picometer formula. 52.9 into n square by z of z1, z2 you can take. Next 52.9 into n2 square by z2 square. Sir, z2. Now here the 52.9 get cancelled. Now for the lithium, for which orbit is asking? He is asking for the second orbit. Second orbit will become 4. n2 square it will become 4, and the helium will be 2 pi. Here the for is asking for which orbit? Is asking for the third Bohr orbit. Third Bohr orbit it will become 3 square, it will become 9, and the lithium it is 3. Then it will become how much? 3, and here it will become 2. So 105.8 and equal to 2 by 3 into R of Li plus 2. If you take to the 3 to the left hand side and this to the right hand side, then it will become 105.8 into 3 by 2. If you do, you will get the radius of Li plus 2, that is approx 159 picometer. Okay, good. Now next one, another question I will give you. Next question. If the radius of first orbit of H atom is x angstrom, okay, then the radius of second Bohr orbit of Li plus 2 ion is. Sir, one more question based on this, please. I will try. That what I was giving. You can try. Option A 3 by 4 x angstroms. B 4 by 3 x angstroms. C 3 by 6 x angstroms. D 9 by 4 x angstroms. Now may I know the answer which is correct for it? May I know what is the correct answer for it? May I know what is the correct answer for it? Enemy boy, good. Answer is B. Answer is B. Answer you have chosen it as a B. Answer is B. Right. Answer is B. No, answer is B. You can cross check. Answer is B actually. See what is asking. Radius is asking, right? Is saying the first Bohr orbit. R1 by is asking for the Ri Li plus 2. First Bohr orbit of the hydrogen atom is x angstrom. You can see first Bohr orbit of the hydrogen atom and the lithium plus 2. Clear? It is 0.529 N1 square by Z1 by 0.529 N2 square by Z2. Now this hydrogen atom radius already they have provided that it is having the which one, x angstrom, and this hydrogen atom it is 1 first orbit and the hydrogen atomic number is 1. So here the 0.529 will be get cancelled. Then x by r Li plus 2 is equal to, here what we are having, n square of which orbit is asking? Is asking of second orbit. Second orbit means 4 by 3. If you take it to the which one, to the numerator, then it will become x angstroms by r Li plus 2 is equal to 3 by 4. Then if you cross multiply 4 by 3 x angstrom is equal to radius of Li plus 2. That's it. Simple. So the answer is B. Sri Vishnu Teja, answer is B. My dear friend Vishnu Teja, try to be in the class, not to be focused on the other extracurricular activities. నువ్వు మా క్లాస్ మధ్యలో వెళ్ళి సార్ మా మమ్మీ పిలుస్తుంది, సార్ మా దోస్తు పిలుస్తుండు, సార్ నా ఫ్రెండ్ ఫోన్ చేసిండు, క్లాస్ మీద కాన్సన్ట్రేట్ చేయి. రైట్, ఓకే, రైట్, ఓకే, ఫైన్. నెక్స్ట్, సార్ నాది చూడు అంటావు. విచ్ వన్? నాది ఆప్షన్ నేను పెట్టిన, ఫస్ట్ నేను ఆన్సర్ ఇచ్చిన నువ్వు అనేవాడివి. ఇప్పుడు క్వశ్చన్ కూడా త్వరగా సాల్వ్ చేసి సార్ నేను ఆన్సర్ పెట్టినా అని చెప్పు, ఓకేనా? నెక్స్ట్ క్వశ్చన్, షుడ్ ఐ గివ్ ద క్వశ్చన్స్ ఆర్ షుడ్ ఐ మూవ్? ఒకటి ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ మీద ఒక క్వశ్చన్ చేద్దామమ్మా. ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ మీద ఒక క్వశ్చన్ చేద్దాం. So that whatever the questions it will be clear. Next, okay, question, lambda of 5000 angstroms falls on metal of work function is equal to 1.9 electron volt. 1.9 electron volt. Okay, he is asking two questions are there. Now in this same question we are having the two types of the questions we are having. One is, first one, energy of photons in electron volt. Okay, B, kinetic energy of photoelectrons in electron volt. Now sim. Okay, I will not give you the options. Okay, Ishwant, I will not give you the options. Okay, you can say A and B. Okay, right. A and B. What is the answer? Say me the answer. What is the B? What is the B? What is the A? What is the B? What is the A? What is the B? What is the A? No, actually, I think it is a integer type question. V is 0.58 electron volt. Suraj, no. I was asking in the units of electron volt. My dear friends, you are doing in the some other. I think so. I was asking, my dear Vishnu Teja, without getting the energy, without getting the A, how you got the kinetic energy? How you got the answer B? If you get the A only, then you will get the B. But without getting the A, how you got the B? Is something is fishy. Here the something is fishy. Anime boy. ఇక్కడ ఏ వస్తేనే బి వస్తుంది. మీకు ఏ రాకుండా బి ఎలా వచ్చింది? సూరజ్, మేబీ ద పవర్ ఆఫ్ గూగుల్, ఐ థింక్ సో. ఎస్ పవర్ ఆఫ్ ద గూగుల్. ఇక్కడ నేను ఇట్లాంటి చేస్తారనే ఐ మేడ్ ఇట్ ఇన్ ద యూనిట్స్. సాయి జోషిత నేను ఎలక్ట్రాన్ వోల్ట్ లో అడుగుతున్నానమ్మా. యూనిట్ ఐ వాస్ యాక్చువల్లీ ద ఎనర్జీ ఐ వాస్ ఆస్కింగ్ ఇన్ ద electron volt. Why you are getting in the power? Why the answer you guys are getting in the power? Joshita, నేను అడుగుతుంది సార్, యూస్ చాట్ జీపీటీ. My dear friends, don't do that type of the things. My dear friends, here I was spending my personal time just to make you strengthen and prove in the chemistry. Please don't satisfy me. Actually, I was giving this live lectures so that it will be useful for you and you will do it by your own and you will get a good academic success in the chemistry. That I was spending my personal life, spending my personal time here. సో డోంట్ యూజ్ దట్ సచ్ టైప్ ఆఫ్ ద చాట్ జీపీటీస్. నేను మీకోసమే ఈ లైవ్ పెడుతున్నాను. నాకేం అవసరం లేదు, ఇది జస్ట్ మీకు ఏదన్నా యూస్ఫుల్ ఉంటుంది అని దానికోసమనే నేను పెడుతున్నా. ఈ గూగుల్లో చాట్ జీపీలలో పెట్టి నన్ను ఇంప్రెస్ చేస్తే మీకేం రాదు. ఇక్కడ నన్ను ఇంప్రెస్ చేయడానికి కాదు ఇది నేను క్లాస్ చెప్తుంది. మీకు ఏదన్నా యూస్ఫుల్ అవుతుంది, మీరు క్వశ్చన్లు సాల్వ్ చేస్తారు, ఏమైనా డౌట్స్ ఉంటే అడుగుతారు, దానికోసమనే తప్పిస్తే ఏదో మీరు నాకు గూగుల్లో ఆన్సర్ చెప్పాలని కాదు. నేను నా పర్సనల్ టైం మీకు ఇస్తున్నప్పుడు ట్రై టు యూటిలైజ్ ఇట్ అమ్మా. నాకేం వర్క్స్ ఉండవా? నేను మీకు తెలుసు కదా, 5:30 వరకు కాలేజీలో ఉంటున్నా. రాగానే ఇక్కడికి రావడానికి 6:30 అవుతుంది. జస్ట్ హాఫ్ అన్ అవర్ కూడా నాకు ఫ్రీ టైం లేదు. 7కి స్టార్ట్ చేస్తున్నా. మళ్ళా అది అయిపోగానే మళ్ళీ సెకండ్ ఇయర్ వాళ్ళకి స్టార్ట్ చేస్తా. నాకేం అవసరం అమ్మా? మీకు గూగుల్లో మాత్రం చూడకండి. వెదర్ ఇట్ ఈస్ అ కరెక్ట్ ఆర్ రాంగ్ నేను 100% చెప్తున్నా మీకు. మీరు ట్రై చేయండి, ట్రై చేస్తే వస్తాయి. ఓకే, నో 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 ఐ వాస్ నాట్ సేయింగ్ ఎనీ, ఐ వాస్ నాట్ ఆస్కింగ్ ఎనీ సారీ అండ్ ఆల్. ఐ వాజ్ ఆస్కింగ్ ఇన్ ఎలక్ట్రాన్ వోల్ట్ కదమ్మా. మరి E/hc తోని చేస్తే నీకు ఎలక్ట్రాన్ వోల్ట్ ఎలా వచ్చింది? షుడ్ ఐ సే? నేను చెప్పాను ఆన్సర్. మీకు ఎలక్ట్రాన్ వోల్ట్ వచ్చింది, నాకు అర్థమవుతలేదు. నేను అందుకే యూనిట్స్ మెన్షన్ చేసిన. ఇక్కడ నేను యూనిట్స్ మెన్షన్ చేసిందే అందుకు. నేను ఇక్కడ ఎలక్ట్రాన్ వోల్ట్ లో అడుగుతున్నా. ఎలక్ట్రాన్ వోల్ట్ లో మీకు కైనెటిక్ ఎనర్జీ ఆఫ్ ద ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ రావాలంటే ఎనర్జీ ఆఫ్ ద ఫోటాన్ రావాలి మీకు. లిజన్ హియర్, energy in electron volt shortcut I was given, right? That is, here the wavelength they have given in the angstrom. Wavelength if they have given in the wavelength is equal to, sorry, this is the one shortcut we are having, right? ఒక షార్ట్ కట్ ఉంది కదమ్మా, ఏంటిది 12400 బై వేవ్ లెంత్ ఇన్ యాంగ్స్టమ్. ఇది 12400 వేవ్ లెంత్ ఎంత ఇచ్చినాడు క్వశ్చన్ లో? వేవ్ లెంత్ హాస్ గివెన్ ద 5000 కదా, 5000 ఇక్కడ పెట్టండి. ఇక్కడ 2 zeros గా ఇక్కడ 2 zeros వెళ్ళిపోతాయి. దెన్ ఇఫ్ యూ divide it, you will get it as a 2.48. You will get the 2.48. Energy in the electron volt, you will get it as a 2.48. You will get. Yes, Suraj, you got it. Yes, good, Nana. Good. Suraj, you got it. Good. I thought you are saying it for the second one. Energy in the electron volt, you will get the 2.48. Then after that, the kinetic energy. Sorry. Now, here we are having the energy is equal to work function plus kinetic energy. This is a photoelectric effect formula we are having. Then energy we got. Now he is asking the which one? Kinetic energy. If you take it to the which one? Work function to the left hand side, what it will get? Kinetic energy is equal to energy minus work function. Yes, Suraj, you have told. I have seen your text now. Okay. Now the energy we got it as a 2.48. Now the work function he has given in the volt, it as a 1.9 electron volt. Then that 1.9 electron volt, if you keep it here, you will get it as a 0.58 electron volt. 0.58 electron volt. Okay. In this manner, the answer you will get. In this manner, this is a answer for this question. Okay na? అర్థమైందా? క్లియరా? ఇంకొక క్వశ్చన్ ఇస్తా. ఇంకొక క్వశ్చన్ ఇస్తా. The ratio of time taken by the electron in revolution. Okay. In revolution round in the hydrogen nucleus, in second and third orbit is. Okay, my dear Vishnu Teja. Okay, fine. Try to focus to the class. The ratio of the time taken by the electron in the revolution round in the hydrogen nucleus in second and third orbit is. Ratio is asking. Revolution is asking. Ratio is asking and the revolution is asking. The time taken by the ratio of time taken by the electron in the revolution round in the hydrogen nucleus in second and third orbit is. Yes, good. 27 is to 8. 27 is to 8. Yes. 27 is to 8. Good. 27 is to 8. Good, Sai Vaishnavi. Good, Anime boy. Good. Good. Now. Yes, 27 is to 8. Good. Right. Now, uh, now the max to max, it is 8:30, right? Now 8:30. Hey, good Nana Akshara, good. Cheppu Vishnu Teja, repeat it again the previous one. Which previous one? This is the previous one. This is a solution for the previous one. You can cross check. This is the formula. One formula I was given. This is the one formula I was given. Now, should I give the one question or shall we extend the class up to 8:45? No, 27 is to 8 you will get, anime boy. 27 is to 8 you will get. Should I extend the class or we'll see tomorrow? So, okay, fine. Okay, sorry. Just 10 minutes. 10 minutes I will explain. Just 10 minutes. We'll do some questions on the Bohr radius. We'll do some questions on the Bohr radius so that in your upcoming exam there is no any misconceptions on the Bohr radius questions if you are having. Now let me search the questions of the Bohr radius. Bohr radius questions let me start. Okay. One interesting type of the question, just one interesting type of the question. He is saying that in a hydrogen atom, in hydrogen atom, don't see in the Google or anywhere. Try to do it by your own. If you are not getting, you can ask me. Okay, you can ask me. I will explain. Okay, in hydrogen atom, an orbit as a diameter having diameter of about diameter of about 16.92 angstroms. Okay, 16.92 angstroms. Then what is the maximum? What is the maximum number of electrons? What is the maximum number of electrons that can be accommodated? That can be accommodated. So see the question carefully, my dear friends. See the question carefully. I was not given the any radius. I was given the diameter. So use the diameter and say me the maximum number of electrons that orbit can accommodate. Maximum number of electrons that orbit can accommodate. Maximum number of electrons that orbit can accommodate. See how the questions he has interlinking. He has given diameter, then he is asking maximum number of electrons that can accommodated. The maximum number of electrons that can accommodated. Maximum number of electrons that can accommodated. The maximum number of electrons that can accommodate. Vishnu Teja is asking me to explain. Vishnu Teja is asking me to rest other. Rest any other? Rest any other? I will finish the class in within 5 minutes. Within 5 minutes I will finish. With this type of the question, with this question I will finish. Suraj explain. Now, Suraj explain. Rest other, any other? Are you trying or should I explain? Should I explain? Should I explain? Okay, right. Now you see, here we know diameter. Diameter is equal to 2r, right? Diameter of the circle is 2. 1 minute, sir. I will give you diameter is equal to 2r. Use this formula and try to do. Use this formula and try to do. Diameter is equal to 2r. If you use this formula, you will get. Easily you will get. If you use this formula, diameter is equal to 2r, you will get the answer. Diameter is equal to. Good, Yashwant, good. How much? How many electrons you got? 8 electrons. Huh? No, not 8 electrons. No. Yashwant, you have tried, but the total number of electrons is not 8. That is not 8. R is equal to 8.46. Yes, good. Yes, Yashwant, you got it as a R is equal to how much you got? 8.46 you got. Yes. Then after getting the 8.46, then what is asking? Then what is asking? R, radius of an orbit. Radius of an orbit Rn is equal to 0.3, let's take 0.3 n square by Z. Z is the hydrogen atom. Z is a hydrogen atom. How much you got? Radius 8.46 you got. Equal to 0.53 into n square by Z. N square by Z. Now, if you send Z is in the hydrogen atom, it is 1. Good. It is 32 electrons. Now, if you send the 0.53 to the left hand side, then the 8.46 by 0.53 equal to n square. Equal to n square. Then if you send the square to the left hand side, then the n will be equal to 4th orbit. N is equal to 4th orbit. No. N is equal to 4th orbit, right? Now 4th orbit contain how many electrons? First orbit is the 1s2, maximum to maximum 2 electrons. Now second orbit 2s2, 2p6. Now it is having the 2 plus 6, total 8 electrons. Now n is equal to 3, 3s2, 3p6 and 3d10. Total electrons are 18. Now n is equal to 4, 4s2, 4p6, 4d10 and 4f14, right? Total number of electrons are how many? Here 10, here 18, 18 plus 14, 32, right? 32 electrons. Total 32 electrons. No. Maximum number of electrons that 4th orbit can accommodate 32 electrons. 32 electrons it can accommodate. Is it clear? Not 38. 32 electrons, not 38, 32 electrons. Maximum to maximum it can accommodate the 32 electrons. This is one very interesting question. See, this type of the questions also they will ask. You have to be very careful. Now you can see here the diameter. Diameter he has given. From this diameter you have to find the radius. After the radius, from the radius you have to find the n. From the 10 he is asking the n. Okay, right now. Okay, fine. Now if you are having any concerns, you can stay in the live regarding the any questions if you need, and the remaining they can leave. If anyone are having the any concern regarding the concept or regarding the any academics or anything, you can ask me. Rest other they can leave and they can you can have your dinner and take some rest and do your respective other subjects. If you are the NEET students, do the botany, zoology as well as physics, and if you are the JEE students, do the physics as well as maths. And if you are the MSET students, do the maths as well as physics. Okay? Yeah. Okay, my dear students. I hope the last question is very interesting. I think so. Question interesting on the last question? No. I am from India. I am from India. Okay. Should I end the live? My dear friends, should I end the live? My dear friends, tomorrow in the class, I will explain classification of periodic table. Classification of periodic table, we are going to end. Yes, yes, of course. Right, right. Okay, Nana, bye. Bye, Ishwant. Bye, Suraj. Bye, Joshita. Okay, fine. Okay, okay, fine, fine. Bye, Vishnu. Bye, Akshara. Right, right, right. Okay, Nana. I was ending the live. Now we'll see you tomorrow. Good night. Good night, Ashwant. Good night. We'll see you tomorrow. Bye, Vishnu. Bye.